All right, let's look at this one. Find the slope of the line tangent to the curve that at the point 4, 3. And there's a typo on here. That's supposed to be equals. So let's see. Or I'm sorry, the equal is supposed to be minus. 5x minus 10. All right, so looking at the graph on Desmos, it looks like a sideways parabola. But let's work out what the derivative is using implicit differentiation. All right, derivative of y squared is going to be, I'll do this big, derivative of y squared is going to be 2y, y prime. Derivative of y is just a 1 times y prime. Derivative of x is 1 over 2 root x. And derivative of 5x is 5, and derivative of 10, of course, is 0. So we'll move this term over there. We'll get y, let's see, 2y prime plus y prime equals 5 plus 1 over 2 root x. Then we'll divide both, we'll factor the y prime out over here. And then we'll divide both sides by 2y plus 1. And we get for our y prime is 5 plus 1 over 2 root x. Normally I don't like compound fractions, but I'm going to leave this one like this because all we've really got to do is plug one number into it. So let's don't worry about rationalizing and doing all that stuff. Okay, so we've got all of that, and we're supposed to find the slope of the tangent line at the point 4, 3. So I'm going to move all this over. I'm going to plug in 4, 3 into this. So y prime evaluated at x equals 4, y equals 3 is going to be, let's write this big, 5 plus 1 over 2 root x, x is 4, divided by 2y plus 1. So 2 times 3 plus 1. So let's see, that's 5 plus 1 over, square root of 4 is 2, 2 times 2 is 4. On the bottom I've got 7. So let's see, that's 21 over 4 divided by 7. So that's 3/4. That's our slope. Let's double check this the sort of cheap and easy way. I've got the thing graphed on Desmos. So let's just check and see if that's the right slope. I'm going to do this by putting in, let's see, our slope we said was 3/4. I'm just going to put in the line y equals 3/4 x plus b. And instead of working out what b is, not that it would be that hard, but instead of working out what b is, let's just adjust this and see if the slope looks right. Yeah, the slope looks dead on for that to be the tangent line there. And it looks like our b should be 1/10. Now, I'm not certain about that. If we zoom in, yeah, it's not quite on there. Okay, that looks dead on, though. B equals 0. Actually, yeah. So anyway, just by sort of putting the right slope in there and fiddling around with it, we can see that does look like the correct slope for this problem. All right, let's look at the next problem. Find y prime given this. All right, derivative of x squared is going to be 2x. Derivative of y squared is 2y. But we've got to multiply by the derivative of y, which is y prime. All right, equals xy. So you get first times derivative of the second plus second times derivative of the first. All right. So let's see, solve for y prime. I'm going to move my y primes to one side. Tell you what I'm going to do. Let's move the y prime over there and the 2x over there. So I get 2y prime minus xy prime equals y minus 2x. So I get y prime is equal to y minus 2x over 2y minus x. 2y minus x. It's not written very well, but that's good enough. All right, tell you what, instead of just plowing through to the next example, I want to do this one again, and I want to do it using Leibniz notation. In Leibniz notation, the derivative of y is the derivative of y with respect to x. The derivative of x is derivative of x with respect to x, which is just 1. And it makes good sense there, dx over dx. You can kind of think of that as canceling and giving you 1. So let's do this again, at least the first step. So the derivative of x squared is going to be 2x times the derivative of x with respect to itself. Derivative of y squared is going to be 2y times the derivative of y with respect to x. And then on the other side, we get equals. Running out of space, I'm going to do it below here. We get the first, x times the derivative of y with respect to x, plus the second times the derivative of the first. So notice on all of these, though, the derivative dx over dx, those cancel away and give you 1, and it gives you the same thing that you wind up with over here. All right, let's do the next example. Find y prime given that x sine y equals y. Okay, over here we've got to use the product rule. So on this side we'll do the first times derivative of the second. Derivative of sine is cosine y. But then by the chain rule, we've got to multiply by the derivative of what's inside. And maybe there's two things going on. So this is the first derivative of the second plus the second times the derivative of the first. I'm going to write the 1 in there just for completeness sake. So this is second times derivative of the first. All right, then on the other side, derivative of y is just y prime. So let's see. I'm going to swap. Actually, no, I'm just going to take this and move it to the other side. So over here, we still have sine y. On the other side, we've got y prime minus xy prime cosine y. So you get sine y is equal to y prime times 1 minus x cosine y. So you get y prime is sine y divided by 1 minus x cosine y. And that's it. All right, I think we'll stop here.